Okay, are you able to see what we're writing? Okay. So that's what the question reads. The question reads that the engineers at Toyota, they have a new steel belt radial tire, and they have estimated that the mean mileage, which is our mu, is equal to 60,500, and the standard deviation is what? 5,000. Then can you calculate the probability that this tire mileage will be able to last for more than what? 40,000 miles. So one thing that we need to learn from here is that when you're calculating the probabilities, always our answers range from the range of 0 to what? To 1, right? They are from 0 to 1, the probabilities. They can never exceed 1. So now, if you observe and look at these numbers, they're really big numbers, very giant numbers. So what we need to do from here, we need to convert these numbers into a number that is very small. Usually the numbers that you convert into, it will be just maybe a number from 1 up to 4 somewhere. That one is called a z-score. Okay, then a z-score is what will help you to find the probability. Did you get it? So number one, you find the z-score that is given as x bar minus mu or over the standard deviation. You're following that? Are you able to follow? Not x bar, sorry, x, just x. X minus mu over the standard deviation. We're calculating the z. The idea behind calculating the z value is to do what? It's so that you can easily find the probability. Remember, all the probabilities are already computed on a standard normal distribution table. They are there. But for you to identify which one is which, you need a what? You need a z-score. You need the z value, which we call a z-score. Is that okay? Those who are online, are you okay? Agnes, are you fine with your friend?
Yes, sir.
Therefore, your x shall be what? 40,000 minus your mu, which is 36,500 divided by the standard deviation by 5,000. When you do your computation, you find that your z is equal to 0.770. Is that okay? Did you hear that one? Did you get it? Codimavera. Yes. If you have heard, this is what we are going to do. This z-score value, this z value is what is going to help us to find what? To find the area. The area that corresponds to 40,000. Remember, this is 0.70 now. It's no longer 0.70, but it is interpreted as 40,000. Okay. So when you say z is equal to 0.70, we mean z or the x value is equal to what? 40,000. Are you following? Right? So now, from this table, the standard normal distribution table, you know that the z value is usually somewhere here, right? And your 0 here, then this side is the negative, right? The total area under this curve is what? What is the total area? It's 1, isn't it? Or the total probability is 1. So when the question asks that, what is the probability that, this area will be equal, okay, will be equal to what? To 40,000. What do you mean? We are asking for this area from 0 up to what? Up to 40,000. Okay, it means that we are interested in space. Yes. Are you having Google Meet or Zoom? Because it's a Zoom link. Sorry? Okay. So, what is there from here now? I said that if you're asked, if the question was asking that, what is the 40,000 years, like exactly 40,000 years, it could have implied the same as finding the area from 0 up to what? Up to 70 here. From 0 up to 0.70. You're following, right? But the question says the area exceeds, meaning finding something that is like the probability or the area that that X lies after what? After 40,000. That is to say A lies after what? 0.70. This is the area that you're doing what? You're looking for. Are you following, right? You're looking for this area. You're not looking for this one or this one. You're specifically looking for this area. You're following? So how do we do it now? You go direct to your table and look for 0.7 and 70. That's full table. And give us the number that you find. The one that gives you the cumulative values from here up to here. The one that is shaded. Yes. Agnes, what do you find? I don't have a table. What are you finding? Yes, what are you finding as the total area from here? You go where there is 0.7, where it means with 0.00 here, somewhere here, where it means. What number is there? You know where 0.00 is? Like on top. Yes. Then where they meet with 0.7. What do they meet? What number is here where they meet? Do you have the number? 0.7580. What do you find? 0.7, yeah. 0.758 what? 80. So it means that the total area from here up to here is what? Is 0.758 what? 80. This is the area from here up to here. But you are interested in which area? This one that is afterwards. So what do you do? Since you know that the total area is 1. What do we do? What do you think we can do? If the total area under the curve is 1, the whole area is 1. But we already know this part that is 0.75. Then we want to find this one. How will you solve the equation? Yes, we can say 1 minus this value that we have found, so that we can just get the remaining part. And what is the remaining part? 0.2420, isn't it? Is it? Yeah, so this 0.2420 implies what? It implies the area that is after this Z value. This is the area that is greater than what? 40,000, or the area that exceeds 40,000. Is that clear? You guys who are online, are you following?
Yes, sir.
Okay. Do you have any questions? You can even ask your question if you have any.
I don't have a question.
Yes. If they give you the thank you. If the question was, can you find the probability that the tire mileage will be 40,000? The question is not saying we exceed 40,000. Now it is saying will be 40,000, meaning you are interested in which area now. Instead of the whole full this area, you're just interested in the area, this area. That's the area that is equal to what? 0.70, which is same as 40,000, right? So how do you find this area? Or what you do, you already know that this area from this side, from here, going this side is 0.5, right? So in this figure, you just subtract 0.5, it will give you this other part. You know that from here up to here is 0.7580, right? Then from here up to here, you see 0.5. So just subtract this part so that you remain with this part. Is that okay? So what you can do, you can say 0.7580 minus what? Minus 0.5. That will give you for the probability that Z is equal to 0.70. Is that okay? Is it okay? Are you okay? Are you fine? You can ask as many questions as you want. Ask me. What's your question? You don't have a question. You don't have a question. Okay. Yes, madam. Zero point 2580. Yeah. So this is the area that is Z is equal to 0.70, not greater. You get it, right? Because this one is for greater. The one that we are finding is for greater, like for what is after. So what is equal is that, okay? But if they ask you what is less than this, what is less than 0.70, which is less than 40,000, right? It will be all this area this side, which means they are asking for the area from here up to here, which is the same as what? 0.7580. Is that okay? Okay. So we have understood, we can move forward, right? Now, sometimes you can be given a question where these things are already what? Calculated, okay? Like the questions are already calculated. Who has the test that you wrote? You didn't come with it? The test that you wrote. I want to select a nice question from there. Who has it? I don't know. The phone is there. So I'm just copying the question, copying the parameters, then I'll be okay. Okay? Yes. Yeah. Beran, man. The question that you have, or the question that you wrote, question number 3 in your test. Question number 3 of your test. It had the following, that the Z is normally distributed with the mu 0 and the variance of 1, which is same as the standard deviation of what? Of 1. Then the question was that, can you do what? Find the value of Z such that, oh, this was good, eh? P Z is less than Z1, which is equal to 0.6985. We want to find the critical value. That's the question. P and Z is greater than, we wanted to find the value of Z. If you're given that Z is greater than that, you have 0.0526. And the probability for Z is equal to Z 0.9750. And the last one is P Z is equal to Z1, which is equal to 0.0045. Oh. What did you do? How did you write this down? How did you solve it? Agnes and the friends, are you able to see what you're doing now? Are you able to follow? We're just copying the question number 3 of the test that you had.
I'm following, sir.
Okay. Okay. So number 1, they're saying the probability that the Z is less than the critical value Z. Okay. Meaning we're looking for the area that is less than the critical value the critical value, this area. Are you able to follow? This area that is the less than it. If it is less than this, it means it's some area here. Then they're saying that when they calculated, so you can speak slowly because we are not getting what you're saying. Okay. What is there is these people already calculated this. Imagine this is a certain number it is here. They already calculated and found the area 0.69885. You're following it? So this area, follow nicely, this area 0.6985, it is said that it is the area which is less on the left side of the river. So how do we find that area? You go straight to your table and look for this number. You're going direct to that table, the table that gives you this one. You know, this table, this is the table that I'm referring to. Yeah, they're saying they want the one that has got the left, the one that gives you all the area on the left side. You know that always, since this is positive, we want something that is less on this side. You get it, right? Are you able to follow? Yes. Can you go to that number, find this number on the table? Are you able to locate it? Where is it? It's here, right? Which means it's only the two decimal places is what? 0.5, right? It is 0.5 plus. Give me the two decimal places upward. Plus 0.02. When you add these together, it will be 0.02. Let's put 0.02 here. We are adding them. When you add, you have 0.52. Isn't it? Right? That's for the area that is massive. So as the Z value. Those who are online, are you able to follow?
Yes, sir.
Yeah, you've gotten the criterion that we have used here. We have gone to that table and looked for this number. Just the way how we are looking, we're doing for the Z statistics and the T statistics. Just look for this area, then move to the right, move to the left, move to the left, then move upward and add. You got it? If you want now, vice versa, if you want now, do it like this, right? Let's invert if you are going to find this as an answer. Let's say this is our Z value. Z is less than this. Let's create this as a question now. The question is Z is less than what? 0.552. You're following, eh? I told you that how do you find this one? The first thing, number one, is to break this down into two as 0.58 and 0.02. You're following, eh? Can you go and follow this line for 0.05? Like 0.05 or 0.5, sorry. Then upwards, you get 0.02. And take the number which is here. It is the same answer, isn't it? And this area, according to that table, to the table that we have used, it is the area that is the lesser, right? Yes. Are you okay now? Are you fine? The side is speaking so far. You okay? You're fine? Agnes, you okay?
Yes, sir.
Okay. Thank you. Yeah, the question was a little bit strict. Yeah, same. It was just interesting. But this one is very interesting as well. Okay. You know, this one is very, very, very interesting. Now, this one they are saying we want the critical value that is greater than, but they're saying this area lies after the Z, isn't it? Just put this as a number. So it's some area that is on the greater side, like it comes after Z, meaning it's somewhere here. Okay, put this as your Z1. So it's somewhere there, isn't it? This is the area. Now this area is what? It's alpha. It's your what? It's your alpha. And they're saying this alpha is what? It's greater than. The area that gives you on the x-axis, the greater than. You have the two tables, right? Go to that table which gives on the x-axis, the one that is shaded on the left side, this one. You've gone there? Have you gone there? Then can you look for this number? You're looking for the 0.0526. Locate this number. Just locate it. 0.526. Zero point 0.05, sorry. 0.0526. That is the area that you're looking for. You found it? It's where, what is the single decimal place? On the left, what do you get? Negative. So now, since it's greater, it's on the right, we'll take it as an absolute value, okay? We'll ignore the negative. It is what? 1.6 plus what? When you move upward, what two decimal places you get? 0.02. When you add these, what do you get? 1.62. Is that clear? No. You're not close, right? Okay. In front of yourself. If you want, we can prove, right? Using the other table. If you want to prove using the other table, you can now using that forward 1.6 and 0.02. You go to the full table. Can you go to the full table first? And we go in the line where the 1.6 and where the limit is 0.02. Like you give me the number. Like you go using the full table now. You go here 1.6 comma, 1.6 here. Where they meet here. What number is there? I mean using that full table, the one that is shaded from here up to here. We are proving using the other table now. So that you see that you can use both tables. Zero point 94774. You're following, right? This is said to be the area from here up to where? Up to here. You're following, right? So now, to find this side that we want, the greater side, can you say 1 minus this? What do you get? We say 1 minus this area, we get the area that is upward. What do you get? Exactly, which is the same question, right? It has given you back this other question. You saw that it was easy. Agnes and the friends, do you have any question or are you following the idea behind this? So we have proven that once you subtract, if you use the other full table, right? You subtract this full area from 1, you get still the same answer. Now you get your answer, it will improve. You get your answer. It means you can move to the right and to the left. Do you have a question, madam?
Yes, sir. So I've got a question.
Yes.
We found the answer to be 1.62.
Yes, it's 1.62. Yeah.
So it can be more than 1.
This is our Z. So our Z, here Z is equal to what? Is 0.05. For the left one, this one is the 1.62. Yes, madam, you can ask now.
1.62 is the area.
No, like it's a critical value. The question he was asking, can you find the value of Z? So you're not looking for the area. Actually, what you are given is the area. These are areas, okay? Then there is a definition here that says this area, for example, this one, it is on the greater side of the Z value, okay? Then for this one, they say this area is on the lesser side. This one, they say it is equal, meaning it is exactly, not on the right, not on the left. I'll show you how to do that. And
so we're finding the critical value. We're finding the critical value.
Yes, exactly. You have it. We are given the areas, we are finding the critical value using the areas. Okay, this is more like the same thing that I gave you under this statistic, if you remember. Under this statistic, we used to have our alpha, right? We would have maybe our alpha 0.025, you remember? Then you get the 0.025 and find the critical value. Do you remember something like that?
Yes, that's what I thought it should do. So that's what I did.
That's what you did?
Yes. So this is something different.
Okay, very good. I think maybe it's just psychological error. Psychological error, because this one we have even proven. You have seen that we have proven that it is right. Let's go to this one. This one says Z is equal to what? Z. Meaning it is equal. Like if you want to visualize, you can visualize like this. So they are asking for which area from 0 up to here. They want this area. Then they have given us that this area is what? 0.7 what? 7.5 what? 50. Let's use the full scale first. You get it, right? Hello? Let's use the full scale for the area that is equal to this. Can you just look for this area? Like look for that area from here. Look for this area on that full table. It is in which line? It is in 1.9. I know. It is in 1.9 and 0.06. Is that true or false? Check. Check in 1.9 and 0.06, isn't it? So, which means when you add this, you get 1.96 as your Z. Therefore, Z is equal to 1.996. Did you get it? Don't panic. Just relax. That is life. We are still learning. There's so much learning. It's good that you are learning now, right? Okay. Maybe it's the way how you're presenting the rate. But otherwise, this is the critical value. You can even flip it, guys, and prove. You get it? Agnes, you okay? Are you okay?
Yes.
All right. The last one is Z is equal to that. So we are basically looking for 0.005. Okay. Let's go direct to that full scale. You can just go direct to that value. Where there is 0.05. We are looking for 0.0050. Let's find that area. What area do you find? Yes, Agnes.
0.2.
It's 1.2.
Just a minute. 0.
Mama, from this one. use that full table.
We don't have
You
it.
can find this for this area 0.0050. It's not there.
We don't have 0.0050, sir.
And so this imperial, this area was gotten in the what? From the extreme. Okay. You got it? It was found. You can find this from the full table. You get it from those my extremes. Those my alpha. Remember there are two tables that are using. So if you now listen, in case I just given a full table and you don't have that one that gives my alpha, you just say 1 minus this one first. 0, 0 at 5. It will give you the area that will correspond to that full table, the one that. And what do you get as the area first? We are still manipulating around the area. 0.995. Now, can you go to that table? You can find it. You're looking for 0.995. Should be able to find it. If you don't find it, then you'll find something that is closer. There's 0.9951. What about the next one? Is 0.994 what? 49.
49.
Okay. At it is 0. Okay, which simply means all in all, it means that they are still in the same line, right? 0.99449, isn't it? When you round this off to the 3 decimal places, it's still 0.095, right? It is in which line? 1.1. 2.5 plus what? 0.07, so that we can have 2.5, approximately 2.57. Is that okay? Are you okay? You guys are fine? Any question? Are you happy with life now? You're not happy? You're not excited about life? Okay. And again, sometimes now, here is something that you need to learn again, very interesting. Let me do the last example. Sometimes now, the Z values will be already calculated, okay? Sometimes the Z values, not the areas, I mean the critical values like these. Remember the first one that we did, we were calculating for the Z value, right? Then now, what if the Z values are already calculated? How do you play around that? It's one of the examples that you have in your, and that should be example number 2. Let's move downward and check. What if the Z value is already what is calculated? So it says, number 1, the first one, Z is equal to what? 0.93. The second one is Z is less than 0.93, and the other one is Z is greater than 0.93. These. And then we can easily do that on using the body. Let's do this, right? Let's do this. Then the other one is Z is between what? Let us find the probability where Z is between negative 1.2, let's say negative 1.20 and what? And the 1.5. Let's look for this one. This is very interesting. Okay, because you should not just get use of what is greater than, what is equal to, what if you want the value that is in between. That's the question. Sometimes the question can ask you for the value that is in between. Okay? You're following me? Let's start with this one. Let's start first with what is less. You just go direct to that table. Can you look for something that is less than 0.9 and 0.03? This number where they need from that full table, the one that moves that like that. That's the area. What is it? Remember, these are not areas now. These are probabilities. They're z values. Okay. What do you get? 0.80, 238, right? What about obviously, what is equal to that? I said you subtract what? 0.5 from this, isn't it? Because when you get this, this simply means that this area is all the way from here up to here. Then what is equal just one to this what? This area. So you know that from here up to here is 0.5, right? Can you subtract 0.5 from this? It will give you for this area that is equal. You got it, right? I mean for equal, we mean the area from here up to here. Then for greater, we mean the area that is upward. What do you find? Yes, like 0.5 from this number. Okay, this number is from here up to here. So you just want to remove this. You get it, right? And you're following? 0.5, this part, in short, this area is for all these shaded parts. Now we just remove this one, this area, which is 0.5. We know that it is 0.5 always from here to this side. No, like it's about from 0.5 is subtracted from this. This number is bigger than 0.5. Should be positive number. What do you get? You have your ID card with you. You have the ID card. An ID card. A student ID card with you. Who has the student ID card with them right now? None of you. Okay. It's fine. What do you get? 0. What? 0.3? 38. Like that, we all agree? Then it means now, for something that is greater than this area is all the way from here up to here, this one. How can you find this one if you are following me? How can you find this one if we know from here up to here? From where? From 1, right? Subtract from 1. Subtract this area from 1 so that it can give you the area that is afterwards. What do you get? What do we really get? One point. 0.1762 as that area after. Do you need to suffer? There's no need of struggling, right? What about this one that is in between? So if you want to visualize, if you are interested in visualizing, this is how you would visualize. You're finding for this area, 1.50 is here, negative 1.20 is somewhere here. Then we want this area that is in between. How can we find the area that is in between? Very important to know. Okay, so first we can find if you want, we can use that other Kasumo table for X. We find the area here, we find the area here. Then we subtract these two areas from 1, we will remain in that. Did you get it? Like you can get these areas in the X-ray. This area and that what? That area. Then you remove them from 1, you remain in the middle part. You got it? Yes. This guy. Do you have your ID card with you? Right now. I'm asking. So you go to that other table that gives the figures in the X-ray. You check for 1.5 where it means it's 1 with the 0.000 like that. What do you get here? I mean the one that gives in the X-ray, not that cumulative frequency table, like the one that gives in the X-ray alpha, the one that is shaded this side. That one. Can you follow where there is 1.5 and 0.00 where they meet? We find that area. 0.0668. What about this side? We go where there is 1.2,0,200. Let's say 1.20.00. What do you get? 0.2? 115 what? 5.1. Okay. 5.1. Then what you do now? Since you know that the total area is what? What's the total area? It's 1, right? You just subtract all you subtract all these from 1. Okay, then it will give you this remaining part, isn't it? You're following the logic? So you say 1 minus minus what? Minus 0.1151 plus 0.0668 like that. When you do that, whatever area you're going to find is the area that is in between. Is that okay? And those guys who are online, do you have any questions?
No, sir.
You are able to follow? Very good. At least you had this very quick revision. Very quick revision. Okay. So now, as you are meditating, those who are online, just wait for a minute. Do not log out. And then you start recording.